Hello students, welcome to my channel Maths with Fun. Today we are discussing the method of Gauss Jordan. So we have three equations in three variables. In this manner, 4x plus y plus 2z is equal to 3, x plus y plus 2z is equal to 0, 2x plus 3y plus z is equal to 4. First of all, we write these three equations in our matrix form. For this, in the first column, we write the coefficients of x. First coefficient of x is equal to 4, second one 1 and third one 2. So you can write the coefficients in this way. Now in the second column, we take the coefficients of y is equal to 1, 1, 3. We write here. And after that, we take the coefficients of z 2, 2, 1. And we write the coefficients in the third column. So in this way, we get a matrix form, and in the right side, we use these matrix. To solve the Gauss Jordan method, we have to make this matrix as in the diagonal form. Now, let's see what is the diagonal form of a matrix. Let me see for 1 minute. Diagonal matrix is a matrix in which its all diagonal elements are present and non-diagonal elements are 0. You can see here we have Aij is equal to constant term when I is equal to j, and when I not equal to j, so we have the term 0. So we have tried our best to take our matrix in this form. So let's start. For this, we have to use operations on our matrix. First of all, our leading coefficients should be 1 in our matrix. For this purpose, we interchange the first two rows. We interchange the first two rows. Like we write here, in the place of 4, 1, 2, we write 1, 1, 2. You can see. In this way, we interchange our two rows firstly, and the operation will be applied on the right side also. Now we move on our next operation. We are trying to make this coefficient is equal to 0. For this, we have to apply the operation on the second row. For this, we multiply the first row by 4. In this way, we have the two coefficients same. When we multiply the first row by 4, then we get, you can see here, we multiply the first row by 4, 1 into 4, 1 into 4, 2 into 4, and we get 4, 4, 8. You can see here, and then we subtract these coefficients from the first row, this one. We multiply the first, I repeat, we multiply the first row by 4, and we get the coefficients 4, 4, 8, and we subtract these coefficients from the second row. Remember that, from the second row. We subtract in this way, 4 minus 4, 1 minus 4, 2 minus 8, and we get 0, minus 3, minus 6. You can see here, we apply the operation on the right side also, because in the right side we have 0. When we multiply 0 by 4 and subtract from the second row, we get the same coefficient 3. So we need not to calculate it. So we get 0, minus 3, minus 6 and 3. Now we move on our third row. For this, we multiply the first row by 2. Why? Because in the third row the leading coefficient is 2 and we have to make this coefficient is also 2. So you can see in the rough work, okay, we multiply the first row by 2 and we get 2, 2, 4, and on the right side also. And after that you subtract these coefficients from the third row and you get the answer 0, 1, minus 3, and on the right side 4. So now you write these coefficient in the place of the third row and you get 0, 1, minus 3, and on the right side you get 4. Now we move on our next operation. You see here, in the second row, all the coefficients are divisible by 3. So you divide the second row by minus 3 to omit the minus sign also. Now we apply the operation on the right side. So you divide R2 by minus 3 and you get 0, 1, 2 and minus 1. You can see here we divide the second row by minus 3. Now we move on our next operation. We subtract the second row from third. Why? Because the coefficient in the second row and the third row, here you can see the coefficient of A22 and A32 is same, that is equal to 1. So you subtract the second row from third and you get 0, 0, minus 5 and 5. You can see here how we subtract, and now you have 0, 0, minus 5 and 5. You again see here both the coefficients are divisible by 5. Now you divide the third row by minus 5 and you get 0, 0, 1, and on the right side you get minus 1. You divide the third row by minus 5 and you get 0, 0, 1, minus 1. Now we are trying to making our matrix as in diagonal form. For this purpose, I have to apply some more operations. Now we move on next operation. We see here that both these coefficients 1, 2 in the first row and in the second row are same. So we subtract R1 minus R2. We have to apply the operation on R1 and we subtract R2 from R1. 1 minus 1 we get 0, 2 minus 2 we get also 0. And the same operation apply on the right side also. Now we have only one coefficient, that is equal to 2. For removing this term, we multiply the third row by 2 and subtract it from the second row. Because in the third row we have only one coefficient 1. and the other coefficients are 0. So we can easily make this coefficient is equal to 0. So multiply the third equation by 2 and subtract from the R2 second row and you get 0. In this way, when we multiply these two matrices, then we get by back substitution, you can also see that we have the solution x is equal to 1, y is equal to 1 and z is equal to 1. So this is the Gauss Jordan method and we are getting our solution. We can also verify our answer. For this purpose, you can put these values in any equation. You can see here, we can verify our answer. Our answer is x is equal to 1, y is equal to 1, z is equal to minus 1. We take our first equation, 4x plus y plus 2z is equal to 3. Then you put the value of x is equal to 1, y is equal to 1 and put the value of z is equal to minus 1. And after solving it, you can see that the value on the left hand side and right hand side are equal. Means our Gauss Jordan method is verified. Now we move on our next method, that is Gauss elimination method. Yes, you can see here. In our previous question, we have a step up to this matrix. 1, 1, 2, 1, 2, 1 and this one is x, y, z and on the right side we have a matrix 0, minus 1, minus 1. We use the same matrix from here. Means in our Gauss elimination method, we proceed as we are doing in our this question, we also doing in our next question. So we use this matrix for our Gauss elimination method and we multiply both the matrices. Now we multiply our both matrix 1, 1, 2. Here x, y, z. Now multiply this row with this column. 1 multiply x, you know very well. 1 multiply y plus 2 multiply z is equal to 0. In this way, we get our 3 equations. Now put the value of z in the equation number 2nd. When put the value of z is equal to minus 1, then you get the value of y. And after putting the value of y and z in your first equation, you get the value of x. In this way, we have our values x, y and z. Now students, you can see that in the Gauss elimination method and Gauss Jordan method, there is very small difference. The only difference is that how we make the matrix in what form. Let's see. In the Gauss elimination method, you have to try to make your matrix in the upper triangular matrix. And you have to make in the Gauss Jordan method as diagonal matrix. So, in this way, you can identify this method and you can also learn it. Thank you so much.